Okay, now I'm just gonna make a session also. I'm gonna post that also at the end of the class on the Google Classroom. Now, what's gonna be the task right now? Okay, let me try a circle. Let me go to okay, now look at this. If you remember, I'm just gonna review a little bit from what we talked on the previous class. Then from the basic things, you can, at the end of the class, you can attempt either the basic exercises on the Google Classroom or the one that you feel ready for the challenge. If you remember in the last class that we mentioned that. We talked about a different measure for an angle. And why is that important? Because it is very important specifically, for example, when you just go to the next year, when you are learning calculus. You see that, for example, in the calculus, I'm now highlighting why this course is important right now today. You see that, for example, you just go to level 5 calculus, and one of the functions that you are just going to work with them a lot is trigonometric functions. For example, we talk about, for example, the sinus of, for example, f of x. And when we are there, you see that sometimes you want to find how the function is changing, how fast or quick is changing. And in that case, you see that you can develop a formula. You say that the function changes, the rate of the change of the function is somehow proportional to the rate of the change of the function f of x, also to the cosine of f of x. That's how the function changes. It's proportional to that. I didn't mean that the function is changing like that pattern. However, in that case, you are going to focus that the f of x has to be represented in terms of the radians, the thing that we talked about that last session. Then this is very important now to learn how to just move from the degrees to the radians in order to just work with more advanced techniques in the math. And that's the thing that it's very important. I hope that you remember this part of the class for your calculus class next year, that the rate of change of trigonometric function is only valid if the function of the trigonometry f of x is measured in radians. However, what is irradiance? As we talked about that last class, we talked about how to convert, how to move from the degrees to irradiance. But what is irradiance actually? Look at this one. I'm just going to define a center angle. I call this angle, for example, it's with the center of the circle. It starts from A, it's the fixed arm, and the moving arm detached itself goes to the B, and I can define this angle AOB. Also, we talked so far that this central angle, the fixed arm of it, has a radius. We call the radius R. We can come to circumstances that, for example, you have a measuring tape. You measure the radius itself, then you use the same measuring tape, you cut the same length on the circumference of this circle. And as a result, if the length of the radius in that circle is R, with your measuring tape, you measure the same arc length as R. For example, if the R is 2 meters, you cut 2 meters as the arc. You start from A and you measure it at the B, then you make this angle. In this case, in this very special case, that your radius is equal to the arc length here. Look at this arc length, R, on the circumference of the circle has the same length as the radius of the circle. If you succeed to do so, we say that, you are so lucky because you measure right now the angle theta that it's equal to 1 radians. And that's effectively the definition of the radians. It can be, for example, any degrees, but we said that in terms of the other measurements, we call that theta measured in 1 radian if the arc length cut by the central angle is equal to the r, the radius. Does it make sense to everyone? Yes?
Omid,
Yes.
does the arc length, is that the one on the sphere?
That the arc length is this, that I'm just highlighting it.
Oh, okay, so if that's equal to the radius, then
That's right.
then the angle is the same as the radius as well.
Exactly. What you do, Ash, is that, for example, you have this radius, r,
Yeah.
in the circle. You measure it with the measuring tape. Imagine that you are a tailor. Now you just use the measuring tape to measure on the circumference of the circle that it measures exactly like the r. If you succeed to do so, you say that, okay, the angle which is formed by this, it's gonna be measured as 1 radians.
What is that in angles?
The angle is here.
It's going to be 1 radius.
That's right, 1 radians. Radians.
Okay.
Yeah, then as a result, 1 radian is in circumstances that the arc length is equal to the radius of the circle. The measure that you get for that angle is now 1 radian. Now, we also talked yesterday. No, it was not yesterday. It was 2 days ago. That in degrees, in terms of the degrees that we have learned so far, how many degrees is a circle? That's right, 360 degrees is one circle, because you can say that, okay, I have 2 half circles, each one is 180, then I have 2 half circles, this is going to be 360. We said that, in that case, we said that 360 is 2 pi radians. That's a fundamental thing in, let's say, which connects geometry into trigonometry. That's a bridge between trigonometry and geometry. Now, then as a result, we said that, I'm just going to go to the next page. We talked about last session, we talked about some conversion methods. The conversion methods that we talked was this. We said that in one case, conversion methods. Sometimes look at that. For example, you are standing between 2 bridges. Look at that. Imagine that's a river. The water is flowing down, and you find a bridge. That's the bridge which takes you from one side of the river to the other side of the river. On one side, you have the angle measured in degrees. For example, 25 degrees. On the other side, you have the angle measured as radians, but they are on two different sides of the river. Now, you need to bridge, you have to walk between these 2 sides. And we talked about the conversion rate in that manner. We said that from degree, if you just want to go to the other side, to go to the radians, you multiply your degrees to what? Anybody remembers? That's right. However, if you are from the radians, you just want to cross the bridge, come to the degree, you multiply that by the inverse of this, which is 180 over pi. That was a thing that we discussed all last class. Now, then in order to cross the bridge, to go either from the degrees to the radians or from radians to degrees, we only need the coefficient to multiply it. Now, as an example, let me just go back. As an example, what we said, let me write it here. We said that degree, the first criteria. We see degree then multiplies into pi over 180. It gives you radians measure. As an example, we said that what? We said that, for example, 45 degrees. How much radian is it? We said that we multiply 45 degrees into our unit of conversion, which is pi over 180. And we see that 4 is a common factor between 45 and 180. Then if I simplify that by 4, it becomes 1. By 4, it becomes how much? Sorry, by 45 becomes 1. And this one becomes 4. Then we notice that then as a result, 45 degrees is equal to pi over 4 radians. We call that rad. That was a thing that we talked about in our last session. As another example, we said that, for example, 90 degrees. It's pi over 80 radians, which is equal to pi over 2 rad. These were the examples that we talked on last session. Ash, you're okay so far?
Yeah.
Fantastic. Now, any questions, guys, so far? Everyone's happy, huh? Now, we also talked about what? How to just move from the radians to degrees. We saw the unit of conversion now is the inverse of that. It's 180 over pi. It gives you what? It gives you degrees. For example, as an example, we talked about what? We talked that, for example, 3 pi over 2 as a radians. How much degree it is? We multiply that by what? 180 over pi. And we notice that. Now, wait a minute. These 2 pi, they are common in between 2. They can be simplified. And the 2 also here can be simplified by this. Then this one, it gives me 90. Then we learn that. Then as a result, it becomes 3 pi over 2 becomes only 3 times 90, which is 270 degrees. Yes, of course, please. And as a very last example that we talked, we said that, for example, how about 2 pi radians? It becomes 180 over pi. It gives you how much? The pi's are going to be canceled out. Then we are left with 360 degrees. That was the thing that we discussed. No questions so far, huh? If you have no question, while learning this stuff, you should be able to just attack the thing which is on the Google Classroom, the basic ones, which is called, I should say, angles and measures. Not ready yet for the challenge. By the things that you have learned so far, you are able to just do one of the exercises. Now, you didn't have the radians on level 3, huh? No. Now, what do we have to do now? We have a kind of an activity to do right now. I'm looking for the circle. Where is that? This is here. Let's have this circle here. We're gonna do a very interesting activity now. This is the y coordinate. This is the x coordinate. Now, stem. Okay, now I'm just gonna cut. Look at this as a piece of cake, the birthday cake. I'm just gonna cut, slice this with different angles that we have learned from level 3 in degrees. Because from next session, we are not going to talk about, for example, 30 degrees. We extensively use instead pi over 6 radians. Now, the activity that we're going to do right now is that now we are going to find all radians equivalent for that. That next session that when we meet, when I say, for example, pi over 6, you know that I'm talking about the 30 degrees angle there. Now, I'm just going to cut it on every part of, we have this one. I call this one, it's going to be 30 degrees. Now I'm talking also today to talk about 45 degrees. We are looking also for all of them. We are looking for the radians equivalent for it. We are going to talk about $60 degrees. And now I'm just going to use the symmetry that we have learned all the time. Now we have $120 degrees. We are just moving, I should say, by 90 degrees from 45 degrees. And I'm just going to build 135 degrees. Now, I'm just going to move by a little bit further, and I'm going to build the angle, which is going to be 150 degrees. We have here 180. We had here 0. Now, I'm just moving a little bit to build by using the symmetry to talk about 210 degrees. I'm moving here. Again, I'm using symmetry from the 3rd quadrant to find 225 degrees. Then the last angle in this 3rd quadrant is going to be 240 degrees. Now, good news, we are moving all the way to the last quadrant. Now, we are here at 300 degrees. And you know, this point is 270. We've measured it, I should say, on the previous part. And I move here to 315 degrees. And lastly, I am moving into this angle, which is 330 degrees. Okay, now These are all the unit circles that we have learned about 3. Now, what we are going to do is that I'm just going to give you 5 minutes. Use the conversion methods. For every individual angles that you see on the unit circle, find the equivalent radians and write next to it. Because from the next session, we are not going to talk about, for example, 45 degrees. We say pi over 4 radians. Now, it's a good practice that when we are there, you know that pi over 4, or for example, 4 pi over 3 becomes 240 degrees. Then you do not get confused, oh, 4 pi over 3 is how much? Or at least which quadrant they are. Because from next session, it's very important to localize which angle based on radians in which quadrants they are located. Now then, please take 5 minutes to do this activity and find the equivalent radians for individual angles. The class finishes at 11 today, huh? Yeah. Okay. Oof, we have enough time. Ash, you're okay?
Yep.
Michelle, you're okay?
Yep.
Awesome. Yes.
Can I ask you a question?
Yes.
For this question, am I assuming that the S1?
For which one? For these ones?
Yeah, for the first one. Okay. Am I assuming that S1 here for the S2 here?
Of course not.
No.
By the S1, what do you mean by the S1? Oh, okay. The arc length.
Yeah.
The arc length from here when it rotates is going to be equal to here. What do you think, Michelle? Of course not, because they have different radiuses. But you can prove that if they are cut in the same angle, but still it's not going to be like the same. There is a little bit trick in there. Let's see if we can do it at the end of the session today. Because I'm going to give some things when I'm just going to teach that lesson. We're going to teach it in the next 5 minutes. I'm sure you're going to do it at the end of the session today. Okay. How far you have done? You started from the beginning?
Yeah.
Oh, okay. Very fast.
Yeah.
What is this? Oh, okay. That looks very fancy. Jackson. Okay. Look how colorful and beautiful it is. Oh, let me just pause the recording, maybe not to take so much time. Okay, now I'm just going to write the radiance equivalent for all of these, and you please keep that, I should say, circle as a reference from the next session moving forward, because we are just going to work just with the radiance. And remember, in order to get all of these equivalence numbers, which I'm going to write, simply I have multiplied everything by a factor of pi over 180. Then if this is 0 degrees, it is still 0 radians. 0 times pi over 80 becomes 0. For 30 degrees, it's equal to what? Pi over 80 becomes pi over 6 radians. For 45, it equals to pi over 4 radians. For 60, it's equal to pi over 3 radians. For 90, it's equal to pi over 2 as we did. For 120, it equals to how much? That's right, 2 pi over 3. For 135, it equals to what? 3 pi over 4. For 150, it equals to 5 pi over 6. For 180, it's obvious, it's equal to 2 pi. For 210, you multiply 210 by pi over 180, you get 7 pi over 6.
Why is it 2 pi?
Oh, sorry, pi. You ought to do this one. My mistake, sorry. It's pi, not 2 pi. There is, because 2 pi is here. It becomes pi, 180 is pi. For 210, it's 7 pi over 6. For 225 degrees, it's equal to 5 pi over 4. For 240, this is 4 pi over 3. For 270, this is 3 pi over 2. For 300, this is 5 pi over 6. For 315, this is 7 pi over 4. For 310, this is 11 pi over 6. And for this is 360 degrees on one complete circle around the unit circle, which is equal to 2 pi. Now, then please, I'm just going to also post that on the Google Classroom, these slides. Just please keep this as a reference that from next sessions, that when we talk about these angles in radians, at least you know which quadrant they are located. It's very important because it decides on to find the symmetries. It decides on, for example, the sign of the trigonometric ratios and many more. Now, any questions? Everyone's happy? Now, this part of the lesson is finished. Now, then you are completely able now to just attack the first problem set on the Google Classroom, which is called angles and measures. Now, we are going to take 5 minutes break, do some relaxation, come back, then we talk about the arc length, and the arc length, then after that, you're going to be able to challenge yourself with those problem sets. Okay? Yes? Now, what time is it now? This is 10:25. Please come back by 10:33. 32, sorry. And from there, then we talk about the arc length. Okay, Ash and Michelle. If you have no questions, please take 5 minutes break. Come back by 5 minutes, then we continue from the arc length. Guys, welcome back. Now, let's go back and continue. Guys, welcome back. The people who are online. I hope you are back. Awesome. Now we are moving. We need 5 more minutes to do something in the trigonometry. Then we should be level with the other classes. Then we just move on from there. Now, as usual, we are always merging geometry with trigonometry. I'm again working with a circle. In the circle, what I'm going to do is this. Okay, I say that. We are talking about now the arc length. Look at this. We say that if we have the same angle, center angle that we talked about that, and we thought that, okay, this is the theta, which I write. Maybe the shape is a little bit so hard to read. This is theta. We say that if we have theta, and it comes from a circle that it has a radius r, in geometry, you can prove that the arc length that it's gonna see, imagine that this one, it's a kind of an eye. These are eyelashes. The eye that you see, the length that you see on this angle, which I highlighted that in green, we say that if we have a center angle O, the length of the arc that it can see and observe, it's proportional to the angle itself. You can prove that in geometry, but we are going to use that result right now. But we say that if the length of the arc is S, then we can show that the arc length S is proportional. Let's call this alpha because I cannot read my theta. I call the angle alpha. Then I say the arc length, which is this one, is proportional to the angle alpha, and we can conclude later, we can prove that the constant of the proportionality, it says that the S, the arc length, is equal to R times alpha. And you see that the R now is a constant of the proportionality. You multiply that by R and it makes it to be a proportion. Then we can think two things. No, we cannot think two things. What I'm saying, we say two things. First, we see that the arc length and R, they are the only two things that they come as a measure. The first observation is this: whatever the unit of radius is the unit of S. What do I mean? If you have measured R in terms of centimeters, then you get the arc length as centimeters. If you have measured the radius, for example, in millimeters, the arc length is also in millimeters. That's very important. The second thing, which is the most important one, and I cannot emphasize that enough, that alpha is and has to be in radians. Now, no question? As an example, I just want everyone now to solve this problem. I say that if alpha is 144 degrees, what is the arc length that is facing that angle? If the alpha is 144. Give it maybe less than 30 seconds to solve it because you already have the formula for it. Okay, how to solve this? You say, wait a minute, it's not that complicated because by definition, we have the arc length is equal to the angle that we have measured facing the arc times the radius. Okay, now you see that, okay, I have the alpha. How about the R? What is going to be the R? I said that imagine that if the R is going to be, for example, 18, 0.20 centimeters, then the arc length is equal to
Sorry, Omid, why is R equal 18.20 centimeters?
I give it as an example.
Oh, okay, perfect. Thank you.
Good question, no problem. I give it an example. Then S as an arc length becomes the alpha times R. I know the R, 18.20. However, it has to be multiplied to the angle, which is 144, but it has to be measured in radians. In order to measure that in radians, I multiply that by a factor of pi over 180. Now, what happens here is this. We have to only simplify the numbers. We multiply 18 times 18.2 times 144. Instead of pi in your calculator, you can round it as 3.14, and the end solution is reaching to almost 21.44. But what is the unit of the length? Is centimeter, because point number one, we said that whatever the unit of the S is a unit of the R. Then if the radius is in centimeter, then the S is also in centimeter. And remember, I used pi as the old thing that we used to think of it. Pi, we took it as roughly equal to 3.14. If you just want to put that in your calculator and make a round value. Any question? Everybody's fine? Now, then you see that now it's a matter of, it's a so easy problem to find the arc length. We multiply the radius times the angle facing the arc, but the angle has to be measured in radians, as this is our point number 2. Now, we move on to the last part. Yes. How much did you get? You multiplied 18.2 times 144 times 3.14 divided by 18. 118, you got how much? 45.7, then I was right. I'm going to double check it later, but you have it in a calculator. I'm just relying 45.7. Okay. Thanks for doing that. Thank you. Now we just go on to the very last part of the class today. Then you say, yes, Jay. Of course, please. Then we are gonna be fully done. What we are gonna do right now, where is the circle? We should have a look at the circle. I said that in the circle, imagine that it's gonna be a birthday cake. You are gonna slice that cake by a knife, and you're just gonna take this out. We are trying to, and as usual, we say that this is a center angle. The radius of this circle is R. Then the question which we ask ourselves, what is the S? I mean the unit, the surface of the slice of the cake that we cut it out from that huge cake. What is the area of it, which we call that the section area? You are looking for this. How to measure it? One of the things that we can do, can anybody tell me how to measure this? That piece of a slice of the cake that you cut it from the whole cake and you wonder, did I get the biggest slice compared to the others? How to measure it?
The area shaded,
That's right, the area shaded, that slice that you took it out.
1/2 pi r squared, or 1/2 theta r squared.
I'm gonna drive this. I'm gonna go one step before that. Doing the things which you already know.
Oh, pi r squared minus the small code.
You mean a fraction, not minus, huh?
Yeah.
That's right. That's what we can do. We say that if r is the radius, what is the surface of the circle? The biggest, I said cut out s prime. The s is pi r squared. Am I right? Yes? Now we see that the slice that we have taken out, it has a radiance, it has an angle as alpha in radians. Correct? Then what do we do here is that in order to find the s prime, we say that, okay, let's put pi r squared, which is essentially the surface of the whole cake before you slice it out. But however, you are gonna take the fraction of it. What is a fraction? We said that if alpha is taken as a whole radiance, we have 2 pi radians of the whole circle, because what we learned in the previous slide. Look at this. We said that 360 degrees is essentially 2 pi radians, which we measured it. Then what do we do here is this. We say that, okay, pi r squared, this is the whole surface area of the whole cake. Alpha is measured in the radians, and I know that the complete radiance is 2 pi. Then it gives me the s prime, the surface area which I cut it and took it out from the cake. Now, we see some very similar, I should say, factors there. For example, we see that the pi is expressed here. And also I have the same pi here. Then if I take them out, we see that the section that we cut is how much? 1/2. This is 1/2 left from here. And we have alpha here. And we have what? R squared. Thank you. Then we see that the section of the cake that we took this out is measured as 1/2 alpha r squared. Then there are 2 things to mention here. The first thing, alpha is in radians. Remember that this is extremely important. If you have it in degrees, it's too bad. The second thing is that unit of R is, for example, centimeter, but the unit of S is squared centimeter, because one is the length, the other one is the area. The area is measured at a squared unit. Now, as an example to finish the day today with this, is that I say if alpha is 15 degrees and R is, let's say, 1 centimeter. What is the section of the cake that you're gonna cut and slice it and take this out using the formula that we developed here? You see, it's very easy. We said that the S is 1 over 2 alpha r squared. You can get S equals to 1 over 2. Alpha is 15 degrees. You multiply that to pi over 80, multiply to 1, and it gives you what? 15 pi 360, and we use the method of centimeter squared. And you can put that in your calculator to simplify that further. Everyone's okay? Just the mere formula, just 1 over 2 alpha r squared. Now, there is 30 seconds to finish the course. Guys, look at this. So far, we use the conversion of the radians to find the area inside the circle. But how about if I just want to see that what is the arc length? What is the arc length? We talked about that. S equals R alpha. Then by the end of the day today that we are done right now, you used how to find the measure of the angles based on the radians. And you use that radians not only to find the arc length, but also to find the section also, which is confined by that arc length. Make sense, everyone? Now, what you can do today now, you can go to attack any of the problems on the Google Classroom. Two easy ones. This is the measures and angles. And the other one is going to be the section area and arc length. And if you feel you are ready for the challenge, you can challenge yourself, but that one is not compulsory. You can do it optional. That's not you have to do. If you have no question, I should say, I wish you a very nice weekend. And I see you all next session. Michelle and Ash, any questions? Bye.
I don't think so, no.
Everything's fine?
Is that everything we've covered in the last week?
It's everything, and these ones are also new because the things that we covered last week, it was just the radiance that we covered it today.
Okay, so we're caught up to speed then. We're not missing anything.
Exactly. We are now
Awesome.
at the right space now.
Okay, that's perfect. Thank you so much. That was really
No worries, Ash. Have a nice day.
You too. Have a good weekend.
Bye, everyone. Thank you.
Thank you, Omid. Have a good weekend.
No worries, Michelle. You have a nice weekend too. Thank you.